This is All India Radio Mangaluru. Dear listeners, in today's Talk in English program now, we will listen to a talk. Is it going to be the end of petrol and diesel engines soon? By Dr. Shashikanth Karinka, Professor, Department of Mechanical Engineering, NMAM Institute of Technology, Nitte.
The general public perception is that electric vehicles are going to come in a big way very soon, and the petrol and diesel engines are going to have a natural death with the impact of the game-changing electrical technology. The death knell for petrol and diesel engines come not from existential crisis of the petroleum fuel and not even from emission of harmful pollutants, but mainly due to emission of global warming gas carbon dioxide causing climate change, as any hydrocarbon fuel when fully burnt produces carbon dioxide and water. No one realizes that in the present form the electric vehicle is more harmful to the environment than their petroleum counterpart, because no one has done a complete study of life cycle assessment of the technology, starting from extracting the ore to the end product, its use and its end of the life waste management. However, in science we cannot dismiss anything as not possible, and we have to welcome any new technology for benefit of mankind. But the technology stabilization takes time. The evolution of the present internal combustion engines and the vehicular technology took more than a century from the state of concept development in 1780s to get its first time used by the people in 1880s. The technology then slowly matured over a period of time, that means over a period of another century, to the present state of development. The period also includes World War I and II and also the Suez Canal crisis and Arab-Israeli war, during which all types of fuels have been tried in the engines, directly or indirectly, solid, liquid, gas and electric. In the conceptual stage, liquid and gaseous fuels were tried in engines. Later, in early part of 20th century, even electric hybrid was also tried, but it was later relegated to the dustbin as other easy fuel alternatives were available. However, the most interesting part is during the time of World War II, when the petroleum fuel availability diminished due to the war. As the saying goes, necessity is the mother of invention. One may be surprised to know that a variety of military planes, a variety of ammunition, firearm devices, the nuclear bomb, the biomass and coal-based vehicles all were invented in a short period of time during the war. During World War II, several lakhs of biomass and coal-based vehicles were used mainly in Europe, some in USA and even in Mumbai, India. However, once World War II ended, with the easy availability of liquid petroleum fuels, for which the mechanical technology of engines and maintenance infrastructure was well established all over the globe, every businessman found it comfortable to go ahead with the known competition without exploring the unknown new technology. Even governments worked on alternative technology only when there was a national threat for energy in the context of global crisis like Suez Canal crisis of 1956 or the oil crisis of 1973 due to Arab-Israeli war. Also, powerful countries, instead of working on sustainable alternative fuels, believed in invading others for the carbon-rich petroleum fuels and saved their shale petroleum in their backyard for future business, never realizing that there will be restrictions for its future use. Although isolated pockets of academics and industries worked on alternative fuels, they never got full support from government or industries, as there was an oil lobby. In the journey of engine and vehicle technology development, the addition of the latest branches of engineering, that is electronics and computer science, helped in a big way for massive change in technology of the present day engines and vehicles. The sea change is that the earlier machines were priced fully for the cost of mechanical components with a very marginal cost of 2% for electrical in it, and the present day engine or vehicle has nearly 40% of cost for the electronics and computer coding. In the 136 years of existence of the practical engines, for nearly 110 years, the engines were bulky, less efficient, less powerful for their size, more polluting, and so on. In 1952, United Nations established the Working Party number 29 and the year 2000 it became World Forum for Harmonization of Vehicle Regulations. Hence, in the last 25 years, with the staged emissions regulations, using the electronics, coding and engineering software helped in making the present day engine very compact, high fuel efficient, less polluting and very powerful for their size and much less time from design to manufacturing as compared to their older counterparts. Despite all these extraordinary technological changes in engines, the global warming issues with the petroleum fuels are compelling humankind to search for the sustainable fuels. Why sustainability and what timeline required? There is a substantial difference when someone refers to alternative or renewable or sustainable fuels. All alternative fuels are not renewable and all renewable fuels are not sustainable fuels. Only sustainable fuels and sustainable energy are needed to mitigate global warming and climate change. The present day electric vehicles, most of it are just alternatives, but certainly not the sustainable alternatives. Hence, enormous energy and time are required to make a sustainable alternative. In the nearly 250 years of stabilization of engine vehicle technology, the names like Alphonse Roches, Nicolas Otto, Rudolf Diesel, Gottlieb Daimler, Carl Benz are etched in the history of mankind for their great contributions. However, Carl Benz is called as father of automobiles for his patent on integrating engine with coach called Motorwagen. Automobiles flourished in Germany through work of Benz and Daimler, and that is why Germany may be called the mother of automobiles. If we benchmark with this history, jumping to a new technology all of a sudden is not possible. Despite the present day technological advancements and the help of artificial intelligence, it may take at least another 25 to 30 years to get a suitable sustainable alternative. In some cases, like when the investment cost and legal procedure, safety and environmental standards are not a concern at all, a game changer technology may emerge at any time and replace the conventional technology, as we see how fast the technology of VCDs to DVDs and floppy disk to pen drive and so on changed within 1 or 2 decades. But the same yardstick cannot be applied to engines and vehicular technology, as it pertains to all sections of the society, and it will have huge impact on politics and economics, as the sustainable aspects include social, economical, political and environmental factors. It would be a Herculean task to satisfy all these needs simultaneously. In the environmental aspect of sustainability of the fuel, the efforts are to eliminate local pollution and global warming components. The fossil-based petroleum fuels are bad polluters and are also bad creators of global warming gas, carbon dioxide. The pollution aspects of petrol engines mainly are CO and SC, and of diesel engines are NOx and particulates. The pollutant gases are controlled at the source. In contrast, carbon dioxide is not harmful as such, but has 300 years to 1100 years of life in the atmosphere, as compared to methane, which has only 12 years of life. To keep carbon dioxide emissions under check, the United States Supreme Court has categorized CO2 also as a pollutant in their ruling of 2009. Will human intervention help in reversing global warming? Yes, knowing is believing. As reported in a Springer-Verlag publication of Germany, in the beginning of engine vehicle applications, identical deaths were reported from several European countries. That when people slept in enclosures like garages with the engine on to take benefit of exhaust heat during the cold weather, and the next morning they used to be dead bodies. This provided proof that the engine exhaust emissions had poisonous contents in it. Further, in due course, two strange things happened. They are called smogs. The California smog or photochemical smog of 1943 and the London smog or classical smog of 1952, and in which thousands of people got affected and killed too. The mechanism of formation of the two smogs are different. London smog happened due to industrial emissions and Los Angeles smog happened due to vehicular emissions. All these incidents made a realization in the humankind to control the engine and industrial emissions. The control of engine emissions initially started in isolated pockets of developed countries. like USA, Japan, and Europe. For example, the state of California in the US was the first to introduce emission legislation in the world. In 1963, as their city topography is very unfavorable for the dispersion of pollutants, today it is believed that in California, the engine exhaust gases are cleaner than the air that inhales for combustion. The staged emission regulations were introduced globally through UN support. For example, Euro 1, 2, 3, 4, 5, 6, 7, etc. in European countries, and the same is called as bar stage 1, 2, 3, 4, 5, 6, and so on. Due to the enormous time and cost involved in making the standards, countries like India adopted the European emission standards as such and made small changes as per local needs and renamed as bar stage. As the stage number increases, it denotes a stringent emission norm. Due to social and economic reasons, there is a phase lag in implementation between the developed and developing nations. India skipped stage 5 due to the already delay in implementation. The stringent stages of emission norms require a lot of changes in the engine, its materials, its strength aspects, the quality of fuel used, the quality of lubrication oil used, and the type of combustion chamber, the number of valves used, the valve lifting technology, the sensor-based electronic fuel injection, and so on. The engine becomes heavier due to high cylinder pressure, and also engine becomes more expensive due to the improved technology. The improved engine is less polluting, compact, high power, and more efficient. It is heartening to note that the UN action on ozone layer recovery has started giving the results by banning production and new use of freon-like compound. Similarly, the UN action on engine emissions control has given substantial benefits. If one compares the streets of Bangalore or Delhi of 20 years before with the present atmosphere, there is a vast improvement. Hence, it is believed that by replacing the fossil fuels by sustainable fuels, we can reverse global warming and climate change. But is the sustainable alternative ready, and what are the technical issues? The answer is not yet ready. Even if we switch over to 100% all electric now, it will bring down only 10% reduction in carbon dioxide emissions, whereas the all electric will produce more carbon dioxide through conventional power generation, more carbon dioxide generated due to battery manufacturing, and increased power demand due to all electric, and also to meet increased energy demand of expected increase in population in the first half of 21st century. A Chinese study of 2017 has reported more CO2 generation in heavy electric vehicles. Also, heavier batteries expected to increase tire wear, causing a new type of pollution. Hence, it is believed that the present-day lithium battery technology is not a game changer, as it is heavy, expensive, and has less range for each charging. Although there is a drastic 85% reduction in the price of lithium battery over the last 10 years, still it is not competitive with the petroleum fuels. Only a drastic chemistry change in battery can make dramatic change in life and energy of batteries. The difficulty with the alternative petroleum is that they do not have both energy density and power density together. Ragon plot for power versus energy densities clearly proves that petroleum fuels are the king. Hence, the engines with petroleum fuels will stay for at least up to year 2035, with 80% of them in passenger vehicles, and even beyond up to 2050 in the medium and heavy vehicle sector. The plug-in electric vehicles will be roughly 40% of total in 2035, and it will be 50 to 60% in 2050. According to Professor John B. Haywood of MIT USA, only 10 to 25% of electric vehicles may replace IC engines in the US by 2030, and replacement for large transport fleets, trucks and ships are not known. Hence, the best option is to improve the engine efficiency substantially. In a vehicle, the engine is the dominant source of energy loss of up to 60%. At present, the engine has substantial scope for energy improvements in the areas such as combustion system, gas exchange process, electrification through hybrid, lubrication oil, thermal and energy management, and so on. Some stable, sustainable technology is expected to flourish in the second part of the 21st century, and also during which the population is expected to decrease. In the Indian context, the biofuels are making a big lead with the 10% ethanol in petrol now, which is compulsory for 20% use by 2025. And in due course, there are hopes of 100% substitution. If that happens, there is ample scope for survival of the internal combustion engines.
Dear listeners, you have just heard Dr. Shashikanth Karinka speaking on the topic, Is it going to be the end of petrol and diesel engines soon? That broadcast came to you from the studios of All India Radio Mangaluru.